Hi, everyone, and thank you for attending today's webinar, Avoiding Costly Mistakes in Solar, Lessons from Field Inspections and PV Module Failures. I'm Kelly Pickerel, Editor-in-Chief of Solar Power World. And before we get started, I just want to go over a few items. You can download the slides for today's presentation in the resource window at the bottom of your screen. We will have a Q&A at the end of the webinar, so please submit any questions in the Ask Question window. If we do not get to your question, our presenters may reach out to you afterwards. You can also expand your view of the slides by using the icon in the top right corner of the slide widget. All the boxes on your screen can be moved and resized to meet your preferences. And finally, if you are watching this webinar on demand, you can still use all of these features, including sending questions to our presenters. If you experience any issues during today's webinar, please try refreshing your browser tab. If you continue to have problems, try closing other apps and browser tabs that you may have open. But you can also click Help in the top menu for more troubleshooting steps, or you can ask our producer for help via the Ask Question widget. So let's get started with today's webinar on lessons from the field involving PV module failures. I'd like to thank CEA for sponsoring this presentation. Today, we are going to hear from Ankil and Claire with Clean Energy Associates. So now I will turn things over to them to get us started.
Thank you, Kelly. Thank you for the introduction, and thank you for everyone who joined the webinar today. Totally appreciate it. So as a brief introduction, my name is Ankil Sanghvi, and I work as a Senior Engineering Manager with Clean Energy Associates. I head the team that does the site inspections and the safety inspections on the PV systems, and have around a decade of experience on the site inspections. I would say at this point of time, all I know is what not to do in solar instead of what to do in solar. And my team has inspected around 860 PV systems across United States. And I have personally been involved into 22 fire investigation supports and 4 wind event investigation supports. What we have found from 860 inspection in United States and fire investigations is 93% of the systems have been found having major safety concerns. If you put that in perspective, every 93 systems out of 100 systems that we inspect have some major issues that can lead to fire life safety or arc hazard or other issues on the site. And from my inspection on the thermal events, what we have noticed is almost all the thermal events I have inspected until now or supported the investigation until now. There is only one event that was due to a major engineering issue. Most of the thermal events that I have seen in my experience could have been avoided by basic due diligence. When we go to the site and start inspecting for the thermal events, a lot of times it surprises me. Why does it have to come to this point for such a simple issue that could have been caught and avoided early on during the design stage or the construction stage of the project? This slide is a very common slide where the problem every year remains the same, where the site owner or the system owner has the long-term interest. Then they hire the general contractor. The general contractor hires subcontractor, and subcontractors hire other subcontractors. What I've noticed is the owners and the engineers have good knowledge on what to do right on the PV systems, but no one knows what the labor is doing, how trained is the labor who is working on site. And what I always say to my clients is most of the issues that we are finding on your site could have been resolved just by bridging the communication gap or making sure that the team who is actually working on the site is appropriately trained. And this is what we have been seeing since past 10 years since I have been inspecting the sites. Is it's the basic communication gap that leads to an issue. A lot of times I've seen laborers working on the PV side for the first time, and they are making terminations inside the inverters while they don't know what inverter means or what inverter is. So this is the root cause or the slide that explains everything in brief. Our industry is growing, and we can see the forecast over here on the growth of our industry. And with the rapid expansion and the growth also means a lot of inexperienced installers, a lot of untrained labor present during the installation. And this is one of the reasons that has caused a lot of issues on the site. And these are some of the top 10 issues that we have from 2023 and 2024. Every 6 months, we put out the list of new issues, and we'll be putting out the list of issues for 2025 in a month or so. But this is the slide for the issues in 2023 and 2024 in the comparison. What we are seeing is improperly assembled connectors has been the top issue of 2024 compared to what we were finding in 2023. There have been a lot of awareness on mismatch of the connectors. You open LinkedIn and I think there is good amount of awareness and education on connectors. They are the small piece of equipment that connects two cables, and they are one of the most underrated pieces of equipment. Cross-mated connectors had been a major concern in 2023, and in 2024 we realized that the cross-mated connectors have, the instances of cross-mated connectors have become better, but what people still are not aware is these connectors come with a specific set of instructions, and they come with a manual, they come with a specific tools that manufacturers recommend to use while on the system, and a lot of system owners or the laborers or the EPCs are not yet aware that these connectors have the manual. Other issues that we have found on the system are grounding issues, damaged modules. Poor termination has been a major concern in 2024, and I know that poor termination will top the charts in 2025 because for many of the sites that we have inspected, almost every site has been found with poor termination. It's an easy fix for the poor termination, and still we are finding it almost on every site. And then wire management issues like cables on sharp edges, and a lot of times we see that the cables are not clipped and they are hanging loose, which has been known to cause issues, and also the water ingress inside the enclosures. A lot of these issues can be found and avoided early on. Myself and my colleague Claire are part of engineering services team, and we get involved right from the design stage of the project. We offer design reviews, design templates, best practice playbooks. They are the guidelines on what to do and what not to do on the PV system installations. And then we do offer milestone construction inspections like substantial completion milestone, mechanical completion milestone, post-commissioning inspection. And Claire is with us. She is the expert on PV module, and her team offers the factory inspections and QA on modules, electroluminescence testing, warranty support, and procurement support. A lot of issues that we have been seeing can be found if there is a due diligence right from the drawing stage of the project. This is one of the issues that we came to know on our recent inspection on the site. If you see the picture on the left, we can see mud and some amount of water intrusion inside the DC combiner box right over here. And On the right, we are seeing the cables terminated inside the terminal blocks of a different DC combiner box. Uh, the team started investigation on the root cause of the water intrusion inside the combiner box. And having water inside an electrical equipment doesn't go well. Water and electricity are not friends, and a lot of times it can lead to fire life safety issues or the arc hazard. Uh, when we started investigating the root cause of the water intrusion on the combiner box, the team noticed that the conduits are sealed, the grommets for the cable entries are tight and correct, and the gasket for the combiner box was intact, so there was no issues with that. But still, we were seeing a lot of corrosion and a lot of water intrusion inside the combiner boxes. Uh, after after some investigation, we found that water was rising through the conduits inside the combiner box due to the level of the ground. There was a slope on the field due to which there was a water collection on few of the spots, which created the water to rise inside the combiner box. I could not put on the pictures on the difference on the grade of the ground due to we don't want to disclose the site. Coming to the second case study, which was one of the thermal events that we inspected in 2024. This is a multi-hundred megawatt site in United States. And they were at the risk of losing the insurance. When they called us, they already had around 6 thermal events, or we say 6 fires on the system. And when we inspected the system, if you see the picture on the top left, we saw a lot of wire management issues. And we can see that the cables are hanging, and there is a movement of wind, and also they were having the issue where the livestock was getting trapped into the cables and yanking the cables. You can see the damage due to these reasons on the picture on the right, where the module leads are coming out of the module junction boxes. That was one of the reasons that led to thermal events on this site. If you look at the picture on the bottom right, we can see the connectors right at the tracker assembly. What would happen if the tracker moves from east to west? Those connectors get crushed, and if the site is operating, it is very, very dangerous situation. And this was the site where the cables were wrapped around the torque tube of the trackers, and as the tracker moved, they kept on damaging the connectors, and we had seen the thermal events due to this. If you see the picture on the left, the picture from the same system that we are talking about, we can see the connector with debris. The picture is not clear, but when I was on the site, I could clearly see the corrosion inside the cribs of the connectors. When they were building the system, the connectors were left open to weather elements. They were not sealed using the manufacturer provided cap, and this resulted into debris and moisture intrusion inside the connector. These are the pictures from the same site. You can see on the top 2 pictures where the connectors are melted, and you can even see the ground in one of the pictures, which is black due to fire. The picture on the bottom left is interesting. 2 pieces of connectors that are not seated, and I have come across 3 thermal events that have had this issue, and that this issue was the root cause of those thermal events. A simple connection of the connectors. A lot of times when the crew is installing those connectors and they are connecting thousands and thousands of them, and the complacency sets in, and mistakes happen. And if the connectors are not seated, it can create an arc fault. Going to the next slide, this is the thermal event that CEA inspected sometime around 2023 timeframe. And when we went on the site, we started inspecting each and every module on the site. And we started going cable by cable on what could, in trying to figure out what could exactly be the issues. Along with this, we were also reviewing the operations and maintenance logs from the past. I still remember I requested the O&M logs from 2019 to 2024 or 2023. And I started going through each and every log. I noticed that operations and maintenance technicians have been recording the issue of melting of connectors due to them being non-seated. And there were a lot of connector issues that were marked down on the site, and they were having a lot of instances of melting of connectors. When I saw the O&M logs, I realized that every time they visited the site, they would find 4 or 5 connectors that were melted. Apparently, after they fixed the connectors, all they would write is found a melted connectors and fixed it. There was no process that was mentioned on how these connectors were fixed. There was no process that was mentioned if the rest of the site was inspected for the similar issue. And apparently, no one even looked at the O&M log. If they would have looked at the O&M log, then they would know that the site is having some serious issues. But it was a ticking time bomb, and finally the thermal event happened. When I was on site, we started going through each module to see and identify the root cause of the issues. And then you can see the picture on the right, top right picture and bottom picture. If you see the bottom picture, that is the connector crib. And you can see beading at the end of the copper cable. The beading happens when there is extreme heat. This helped us determine, and the other evidence around that location helped determine that this was the location for the highest heat that was on the site during the thermal event. And the beading on the copper cable happens when the heat is extensive. Typically, when the crimp is right, even if there is a fire, it's very, very, very difficult to take off the crimp. You cannot pull the crimp even with the bare hands. So we inspected a lot of other cables on the same site. The crimps were intact, except for this one, which one was not intact. And this kind of tells us that the issue for this thermal event was the connectors that were not seated correctly. The above picture, the top two pictures shows the issues regarding the assembly of the connectors where the connectors are not torqued. When we found these connectors, we tried to unscrew the cap. When the connectors are torqued well, you would see the plastic collet and the grommet inside them tightly gripping the cable, avoiding and sealing the cable from the moisture, sealing the connector from the moisture intrusion. So there were a lot of issues on this side that were neglected. Going to the next one, this was one of the events that we visited. And for the bottom two pictures, you can see the cables are under the cinder blocks and the racking, the heavy weight, which pinched the cables. And when we reached on the site, we realized that all the equipment was thrown into dumpster. My team took all the equipment out of the dumpster, which was the evidence, and we started investigating each equipment. What we found on the investigation was there were a lot of pinched cables. If you see the picture on the top left and picture on the top right, And the picture on the bottom, we could see a lot of incidents of the pinched cable for this site, which could have caused the arc fault event. Something that has been surprisingly on the rise in last quarter of 2024 and 2025 is CEA has been getting a lot of calls from the insurance companies and developers regarding weather-related risk. It could be the wind event. It could be hail event. Most of the calls have been related to hail event, and the questions were how to avoid or how to protect the system from the hail damage. The picture on the right is not from CEA. It's from the different website, but this is one of the famous hail event that occurred, and we have obviously seen the news about hail events in Texas, and what we found that in one instance the hail diameter was around 10 inch. Investors are raising concern about PV module compatibility for the regions with higher hail events. This is the data that we have from FM Global, the map that has the different regions of the United States on the severity of hail. There has been a lot of concerns among insurance agencies, long-term owners, and EPCs on protecting systems from the hail event. We recommend always to involve the third-party engineering service right from the design stage of the project. The third-party engineering services like CEA can help analyze hailstorms return interval, the size of the hail, can help procure appropriate modules. And there has been a lot of debate on how to store the tracker during the hail event. There is a data that says that if the trackers are stored at beyond 55 degrees instead of 0 degrees flat, that was traditionally a protocol around before 2020, and we have seen that the damage due to hail can be avoided by 300%. Having said that, I would hand over to Kearns-McCoy, who is my colleague, and she will be presenting on PV module failures.
Thank you, Ankil. As Ankil mentioned, I'm Kearns-McCoy. I'm also a senior engineering manager here at CEA, and I lead our team that does field inspections of PV modules for North America. I'm going to start off by discussing some of the recent trends that my team has seen in our on-site module inspections. So these are trends from inspections of PV modules after they leave the factory. So these inspections take place in warehouses or at project sites in North America. And there's two types of inspections I will be covering today. The first is a visual inspection. So this is where our team is looking for any visible manufacturing defects, as well as transportation and handling damage. Sometimes this is really obvious damage and defects, and sometimes it's a much subtle issue that's observed. The other type of inspection that we do, and that I'll be presenting some findings from, is an EL inspection. You can think of an EL inspection kind of like an X-ray, but for a PV module. So it's an inspection of the module utilizing something called electroluminescence. And through an EL inspection, we can identify defects in the cells and internal module circuitry that are not going to be visible to the naked eye. So EL is a really great tool for understanding deeper into the performance of the modules and seeing defects that may not be immediately apparent. One of the biggest trends we've seen in our on-site inspections over the last couple of years has been the effects from supply chain disruptions. So I'm sure many of you are familiar. There's been a lot of disruptions to the PV supply chain over the last few years in the United States through tariffs, import restrictions, et cetera. And we've been starting to see that effect in what we're seeing in these module inspections on site. The first effect we're seeing is we're seeing a lot more modules being stored in warehouses. And because those modules are being stored in warehouses, we're seeing an increase in transportation and handling damage. This is partially due to the increased handling that's inherent in moving a module from a factory to a warehouse to a site. But we're also seeing this due to improper storage and handling practices while the modules are in the warehouse. We are also seeing, in some cases, an increase in manufacturing defects in new modules. That's due to some of the less established factories that may have some quality issues. This is certainly not universal, but it is something that we're seeing. One positive trend we've seen recently is we are seeing fewer new modules that aren't affected by any sort of handling damage that have cell microcracks. However, we're seeing an increase in other EL defects. So as I mentioned, one of the types of damage that we're seeing increase is increase in damage during transportation to the project site. This is especially something we're seeing in modules that have been previously warehoused. And some of the concerns here that lead to this transportation damage is first, we do see pallets that are damaged during handling and storage at the warehouse. And once these pallets have been damaged, their structural integrity may be compromised, which is going to lead them at risk for further pallet damage as well as module damage during loading into the trucks to ship to the site, as well as transportation to the site. We're also seeing that in cases where modules are being shipped from warehouses to project sites, the warehouse staff may not be familiar with the correct loading configuration as well as procedure that is relevant for that specific type of PV module pallet. And so we are seeing trucks arrive on site with improperly configured modules. Maybe they don't have airbags in the right location, not properly strapped down, and that is leading to an increase in module damage during transportation. The next few slides, I'm going to cover some of the examples of defects that my team has seen in our inspections. These are all, these next few slides will just be inspections of brand new modules. I also want to highlight the percentages of modules affected in each of these is not very high. It's typically just a few percent, but if you consider the total quantity of modules that's on a large utility scale site, it can be in the hundreds of thousands or even millions. This is still a lot of modules that are affected. And it can be a very challenging situation to mitigate once the modules are on site and installed. So the first one to discuss is we've seen defective factory-made connectors. So at this site, 2.5% of the modules that we inspected had a defective connector right out of the box. These connectors weren't damaged or anything. They were unfortunately manufactured incorrectly. And due to that manufacturing issue with the connectors could not be seated properly. And as Ankil has highlighted previously, improperly seated connectors are a really significant safety risk for the site. So not only is this going to result in a challenge installing these modules, it can also result in a safety risk to the site if the modules are left. At another system, we found that 3.5% of the modules inspected had large laminate bubbles at the edge of the glass. These laminate bubbles are a concern as they have the potential to continue to grow during the lifetime of the module. And then also to allow moisture ingress into the module and compromise the electrical insulation between the electrical components of the module and the edge of the glass, potentially leading to ground faults or internal arcing. We've seen, a general trend we've seen is an increase in clearance issues. So there are requirements per IEC standards for certain distances that need to be maintained between electrical components of different voltages within a PV module. And those standards are in place to ensure that the modules are safe, not at risk for internal hotspots, internal arcing, or other sorts of internal failures. And we've generally been seeing more violations of those. So here's one example where we saw that at this site, about 1% of the modules had insufficient distance between the cells. And as you can see in the EL image on the left, the insufficient distance between the cells has led to a point of current concentration, which is that bright spot on the EL image. And were this module to be installed and operated, that point of current concentration could become a hotspot. It could potentially lead to module failure. Another really common issue we've seen is misalignment between the stringing wires and the cells. So the stringing wires are what is used in a module to connect one cell to the adjacent cell. And they are attached at a few points along the cells. And we've been seeing an increase in the number of modules that have some of these really significantly misaligned. We have another example here where you can see a visual defect resulting in an EL defect. And so the dark areas on that cells are going to be areas that are not going to perform as well. And so that cell is not going to perform to expectations. And in really severe cases, you can actually see module hotspots as a result of misaligned stringing wires. As I alluded to earlier, we're seeing an increase in handling damage. And so here is one site where 1% of modules that we inspected had really significant frame damage. As you can see, the frame damage here is going to affect the ability to reasonably install these modules, as well as their structural integrity once installed. And finally, we have an instance of a site where 5% of the modules had some sort of foreign material in the laminate. This foreign material was in a few cases organic, but in other cases it was metallic. And that metallic material was located in a place that did affect the clearance distances that I mentioned earlier that are important to ensure proper insulation within the module. So one of the big takeaways from this is that over the last couple of years, our team has been seeing an increase in defects and also an increase in variety of defects. So we're seeing a lot of different kinds of defects. There's not necessarily one defect category that stands out as an issue across the industry. It's just different defects at different sites. I have a couple case studies as well. So this first case study is the case study of a junction box failure. So this project was utility scale system, over 100 megawatts, and module substring anomalies had been identified in aerial IR, affecting a few percentage of the modules. We went to this site to understand what is causing this, and through our investigation, we identified that the cause was traced down to a specific junction box location on each of the modules. And so we conducted a junction box dissection and identified that in this case, the cause of this module failure was an improperly soldered connection at the factory. So within the junction box, the connection between the module leads that come out of the module and the junction box hadn't been made properly and was able to work itself loose over time, causing that junction box to put the string into open circuit and then the module failure scene. The next case study I have is for hail damage. So as Ankil mentioned earlier, hail damage remains a big concern for the industry. And so this is the case of a commercial rooftop system. So the modules are mounted flat and don't have the option for the tracker stow that Ankil alluded to earlier. This site had two module types. The first one was a glass backsheet module, 3.2 millimeter tempered glass and monocrystalline cells. The second one is also glass backsheet, 3.2 millimeter glass. For this manufacturer, we weren't able to confirm the strengthening of the glass, although it's assumed to be tempered, and had multicrystalline cells. The site had been affected by a hailstorm, and broken glass was visible on about 5% of the modules, but to a naked eye inspection, the remainder of the modules appeared to be okay. We conducted EL testing on a sample of modules to look for non-visible cell damage. So we selected 80 modules. Any modules that had visible damage were excluded. So these 80 modules only consisted of modules that appeared to be in perfect condition based on a visual inspection. And we selected the sample to be representative of both module types present at the site, as well as spread out across the site. Our findings were that even though these modules had no visual damage, 100% of modules from both manufacturers had major microcracks that are likely to affect the performance of these modules and result in these modules to underperform over time. We also found that the number of cells affected was pretty significant. So for module type 1, it was an average of 5.5 cells per module affected by these major microcracks. And for module type 2, it was also almost 5 cells per module. The more cells per module that are affected, the more your performance loss is going to be. And so considering how many cells are affected is a metric to show how severe the damage is. We also found that at the time of inspection, which was shortly after the hailstorm, about 2 cells per module already had an inactive cell, inactive area. And so microcracks may not initially form an inactive area, but an inactive area is going to be a portion of the cell that is isolated and doesn't produce any power at all. Over time, the other major microcracks on these modules we would expect to grow to form an inactive area, but it was immediately after the event we already had about 2 cells per module that had this inactive area. There are a few things that can be done to prevent module defects. First, selecting suppliers that have a robust QA/QC protocol to minimize some of those manufacturing defects mentioned. It's also recommended to conduct third-party quality assurance to ensure that the manufacturers are correctly following their QA/QC protocols that are in place. And finally, it's important to ensure the modules are handled and stored with care. As I mentioned earlier, we're certainly seeing an increase in some of the transportation damage, and so making sure that anyone that's handling your modules is following proper protocols, that if they do need to be stored in a warehouse, they're stored properly in accordance with the manufacturer's guidelines. And that can go a long way to preventing damage. There's also a few things that you can do to mitigate the risks and costs associated with the types of defect and damage that we've been seeing. So first, it's always important to identify module defects as early as possible. The earlier you identify a defect, the simpler it is to understand where that defect came from, the fewer potential opportunities to introduce defects there are present. So you don't have to ask, did this come from transportation, or could it possibly have been on-site handling or installation that caused the defects? The earlier you test, the easier it is to identify when the defects are present. It's also easier to proactively identify defects than to have installed an entire system and then have to ask, why is this system underperforming? It's also recommended to conduct a post-event inspection after a severe weather event. As shown in the case study, modules that remain visibly intact aren't necessarily going to be modules that are still going to perform well. They may have invisible damage that will affect the performance of the modules in the future. And so it's important to conduct inspections as soon as possible after that weather event to identify any additional modules that may have been damaged. And then finally, we recommend when purchasing modules, consider contractual terms around defects and warranties that can help protect you in the event that your modules are found to have defects. With that, I will turn it back over to Kelly for the Q&A.
Okay, thank you. Really wonderful presentation, learned a lot. There are a ton of questions that have come through. They're all really, really good. So I'm going to try to group them together for you guys. Thought first we'll kind of get on the topic of connectors specifically. So the issues that you're finding with connectors, do you feel that it is installer mishandling or manufacturing defect that's leading to these damage?
Great question. I would say 99% of the time, we are seeing the issues with the connector related to installer mishandling. The issues like not capping the connectors, right? And allowing the moisture and debris to get inside the connectors while construction of the system has been major. Once the debris is inside the connectors, it starts corroding the crimp. And when the corrosion happens, the resistance increases, and resistance lead to heat, which leads to melting of connectors. And if you are having the system on the the melting connector debris falls on the roof, it can catch on fire. Now, there has been one instance where we have seen the cracking on the connectors due to the manufacturer-related issue. But most of the times it's install-related issue. Either they are not using the right tools, like torquing of the connectors, either they are not sitting the connectors well, or mishandling of the connectors.
Okay. Along those same lines, just with connectors then, are you seeing this damage, these problems with like UL listed and approved products, or is it more of just cheap products?
Cheap products, yes, but yeah, the answer to this is simple. Cheap product, definitely yes. There have been connectors which doesn't have the manuals, and but coming to the good products, the UL listed products, yes, we have been seeing issues regarding connectors getting damaged due to mishandling.
Okay, so maybe it's not so much investing in high-end connectors, it's more you have to have good installation techniques.
I would not say no to the first part. The high-end connectors, yes, there are some really good companies which provide excellent after-sales support and help you if there are any issues with the connectors. So definitely good connectors are the priority, if that answers the question, Tilly.
Yeah, that's good. Okay. Regarding transportation of like solar panels, would you recommend using connector caps inside the pallets to reduce that water ingress, or have you found issues in the field that appear due to the absence of connector caps?
So a lot of module manufacturers, when they ship the modules, have started offering connector caps while shipping the modules. What we have seen is when the construction starts, racking is installed first, and after the racking is completed in the small section, the crew starts installing the modules, and the connectors are left open to the weather elements for a long time until the final connection is made. So if you have the option to purchase module with the connector caps on, that is definitely that should definitely be prioritized. Plus, if you don't have the modules with the connectors shipped, capped and sealed, then always the recommendation is to buy the caps from the manufacturer so that you can seal the connectors until the final connections are completed.
Okay. Yep. Good tips. Okay. What about on tracker projects? How can the rotation of the tracker tube, how can that damage the fastened connectors? If the connector is being rotated with the tube, how is it getting damaged from the tracker?
So the picture that I showed may not have done the justice, but at this site, the connectors were not being rotated along with the tracker tube. So there were two issues over here. The way the wire management was done, the tracker tube would compress the connectors. And the other thing was the cables were rotated around the torque tube so tightly that when the cables rotated, due to the force, the connectors would come apart. So there were two different issues at the sites that we noticed.
Mm-hmm. Okay. Okay, we have some questions here about EL testing. What level of current would you recommend to inject while doing the EL testing?
Yes, that depends on what you're looking for. There's a few different recommendations for looking for different types of defects. Some defects are best seen at low current, other defects are best seen at high current. We typically go towards the higher current method, which is about ISC, unless there is a type of defect that we're specifically looking for that is more visible with a low current inspection.
Okay. Someone was asking, how do you take the EL picture in the field?
Yeah, so we have a specially adapted field EL kit that can be portable and brought to the field. So if modules are installed, we don't recommend uninstalling modules for EL, as that can introduce additional damage and raise some questions as to whether the damage seen was present in the modules before or was caused by uninstallation. So for installed modules, we do bring our EL equipment to the modules and take the pictures of the modules while they remain installed.
Okay. And then what sample size do you recommend for visual and EL testing at a site?
Yes, that also depends on the nature of the inspection. So if it's for an inspection on brand new modules where it's just kind of understanding the quality, we typically recommend to inspect on a sample. We use the ISO 2859 standard typically to identify what the appropriate sample size is for a collection of modules that we believe should have had similar manufacturing and transportation conditions. For things like a post-weather event, that can also vary in situations like the case study where 100% of the modules are damaged. A sample is certainly sufficient, but in a situation you may have a lower damage, we would recommend 100% inspection.
Okay. How does EL inspection compare to thermal inspection?
Yeah, so for a thermal inspection, you're going to see the most severe defects, but it's going to give you a good picture of how the module is performing at that moment. What EL lets you do that an IR inspection won't is give an insight into some defects that may be present that aren't going to affect the performance right now, but may affect the performance in the future. So one of the big challenges with microcracks, like some of the ones that I showed in that hail case study, is initially those microcracks can actually remain, you'll still have some contact across the cracks. The cell fingers will still bridge the cracks will still kind of remain close to each other, and so you're still going to get an electrical connection over the crack. But with time, as modules are subjected to the normal thermal cycles that happen between day and night, normal wind, you're going to get some stresses applied to those cracks. And those cracks are going to start to open and increase the performance effect. An EL image will identify the cracks that are present but haven't yet opened, whereas an IR is only going to show really severe cracks that have opened, caused inactive areas, and those inactive areas need to be large enough to either result in hotspots or diode activation. Okay.
Again, there's a lot of really good questions, so I'm reading through them all, but please continue to keep submitting them. Someone is asking about hail mitigation measures. Have you guys found, have any certain hail mitigation measures proven to be more effective? Hail detection by sensors or by weather forecasting? What have you found to be the most effective way to track that?
I can take this one. Yeah. So certainly, first of all, the most effective hail mitigation method is going to be whatever you're able to implement on your site. Generally, from what we've seen in data, it is using a forecast-based and proactively stowing when there's a risk of hail is going to be associated with a very small loss in performance if there isn't actually a severe weather event, but that loss in performance is going to be quite small compared to the overall performance of your project over the year. And so generally it's worth it to be proactive on that hail stow and stow when there's a forecast of hail instead of risking waiting it out and potentially sustaining serious damage to the project.
Okay, perfect. Okay, I'm gonna try to group some of these next questions about module quality control. Do you recommend to invest in module quality control if it's most likely that in 10 years or so, the project is going to be replaced or repowered? Is that still important?
Yes, I would still recommend investing in module quality control since you want to make sure the system performs to expectations for those 10 years, and also that you don't have any serious things that are going to result in a module failure and therefore could lead to some serious losses in performance in your project.
Okay. You guys were mentioning the foreign material within the laminate of solar panels. Would that typically qualify a module for rejection against agreed acceptance criteria?
Yes, so typically a module manufacturer will have a requirement for a certain size or location that would not be allowed. So in both cases, the pictures that I showed, that foreign material was located between the module bus bar and the edge of the glass in such a way that it reduced the effective clearance distance. And so that would certainly not be allowed. Many module manufacturers will allow certain small foreign material if it's not believed to impact the performance of the module, but they will have a criteria stating what is and isn't allowed based on their module design.
Okay, perfect. If we're talking about manufacturing defects, is there any rating or a list of suppliers or manufacturers to avoid at any cost? Or is there one that shows like the best ones that have almost no issues, or where should people be looking?
So my recommendation is to look into the factories, not just the manufacturers, because we do see manufacturers that have factories that are in different countries, may have been established for different amounts of time. And so while looking at the supplier is important, it's also important to understand the quality of the factory. And so we recommend pursuing a factory audit to understand the quality of the factory that your modules will be produced in.
Okay, perfect. Remember, you can keep submitting your questions. I'm going to try my best to get through as many as possible. The next question is about connectors. Do you recommend using the same manufacturer of connectors, for example, like the Staubli MC4, with another Staubli MC4, or do you have any issues with, cross-mating connectors? What are your recommendations?
We strongly recommend using the connectors from the same manufacturer. For example, as you said, Staubli to Staubli. Do not mix connectors from two different brands. The issue is the metallurgy of the crims manufactured by the two different brands can be different, and this can start corroding the connectors. And we have seen a lot of companies marketing their connectors as compatible. MC4 compatible. MC4 compatible would only mean that the plastics fit, but that would not mean that they are tested and they have been tested for long term for their meetability. So MC4 compatible is totally wrong terminology and misguiding. And whatever brands you choose for your connectors, make sure that they are the same brand and they have been tested being meetable by the brand.
Mm-hmm. Okay, perfect. This is a really interesting question. You guys mentioned how important connector caps are, but would there be any damage caused to the solar panel if the panels are stored with the positive and negative leads plugged into each other instead of using caps?
Claire, do you want to take that?
Yeah, we would certainly recommend using caps instead of short circuiting the modules.
Okay, perfect. Okay, to make sure any loose connection and insulation defect, the test of the string, are you suggesting that to test insulation, including module without module?
The test for the insulation damage should be the basic test during the commissioning of the project, right? So typically, when the cables are pulled, there should be an insulation resistance test. After the connections are made and the modules are connected, there should be an insulation resistance test to make sure that there is no damage to the cable insulation. In my understanding, I hope that answers the question. That was your question.
Mm-hmm. Perfect. Okay, someone has some questions about rapid shutdown devices. If you guys have any insights in this area, have you found any reported thermal events in commercial systems where the PV systems have inverters with AFCI or rapid shutdown devices to mitigate fire risks?
The answer is yes. We have seen thermal events on the site with rapid shutdown devices. Now, what I recommend over here is to follow the manufacturer's guidelines on rapid shutdown devices very strictly. Install the RSDs per their recommendation. Make sure that there is no crosstalk, and select the right equipment.
Okay. Next question. What are the fundamental tests that you recommend during commissioning? Should they do periodic maintenance, inspection after? What are the fundamental tests you're recommending?
So there are some safety tests that should be included during the mechanical completion of the project and during the substantial completion of the project. For example, the ground continuity testing, the insulation resistance testing, the VOC ISC check, the infrared thermography. These are some of the tests that we strongly recommend. The list is not limited to this, but these are the main tests that I can think of right now that needs to be done during the during pre and post commissioning of the project.
Okay. Cable ties, someone's asking about. Are cable ties an ideal method to manage wire management? And how important is support versus securement?
So National Electrical Code provides the guidelines of the distance between the support and securing of the cable ties. Now, we have seen the issues on the field due to the cable ties that are not UV rated. They break very often and it requires a frequent maintenance. One of the pictures that I showed during the presentation had the cable ties that broke and the cables were hanging. There is also the weight rating for the cable ties, the UV rating for the cable ties, and the metal ties are absolutely a no-no. because we have seen the insulation damage due to the sharp edge of the metal ties.
Mm-hmm. Okay. Where all is CEA working? Someone wanted to know if you're working in Michigan, but maybe are you working nationwide? Where all are you working?
So,
yeah, so our team,
go ahead, Claire.
yeah, Ankil and I, our team services North America, but CEA is a global company, so we do conduct inspections worldwide.
Okay. And then I think this will be our last question, but as a reminder, we have a lot of questions in here and we'll make sure that we'll get you the answers you need. But our last question is going to be advice from you guys. With project margins being so thin, how can we drive the narrative to high quality? As I'm sure many decisions are being made for cheap components or labor. So how can we get companies to start thinking about high quality?
I think I can start off, Ankil, and then if you don't, you can take over. But I think for, especially with module specific, thinking about the O&M costs later, it's much more expensive to replace a module once it's been installed than it is to have spent a little bit more in the first place to have purchased the right module. And so making sure that your cost models have a really realistic expectation of O&M costs and understanding that if your components are poor quality at the beginning, you're going to have to spend more on O&M, and most likely those costs will negate any savings you had up front.
The answer is simple. Prevention is always better than cure. The headache when something goes wrong during the operation of the site is a lot more. So I would suggest initial investment in good quality of equipment, and due diligence always pays off in the long run.
Perfect. Okay, everyone, thank you so much for joining us today on this webinar. If we did not get to your question today, we will reach out to you directly. We ask that you please take a moment to fill out the survey that's going to pop up when this webinar concludes, because we do use that feedback to improve our future webinar programming. This webinar will be shared with all registrants so you can view it again at your convenience. So I would like to thank Ankil and Claire for being here and CEA for sponsoring today's webinar. And thank you to everyone for joining us. Hope to see you at more Solar Power World webinars in the future. Thank you.
Thank you, everyone. Thank you, Kelly.
Thank you.